Section 8-9 is on perfect squares. A perfect square trinomial, we've actually already seen these, is in the form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. And we've seen these before. I think it was back in section 8-4. Now, remember what a perfect square is it's a number or an expression that can be factored into or broken down into two of the same thing. So for example, 25 is a perfect square because it's 5 times 5. In the same way, the trinomial a squared plus 2ab plus b squared is called a perfect square because it can be factored into the quantity a plus b squared. Remember, if we do a plus b times a plus b and FOIL it, we'll get a squared plus 2ab plus b squared. Now, this is where it's going to be helpful if you memorize that formula back in section 8-4, where we went from a plus b quantity squared to the trinomial a squared plus 2ab plus b squared. So here's how you recognize whether or not a trinomial is a perfect square. Are the first terms and the last terms perfect squares? In other words, is the first term something like x squared or 4x squared? And is the last term also a perfect square, something like 81 or 121? Then, is the middle term 2 times the square root of the first term and the last terms? So if this term is x squared and this term is 81, is the middle term 2 times x, which is the square root of x squared, times 9, which is the square root of 81. If it fits this pattern, then you don't have to show any work, and you can just write it as a plus b squared. And then the same thing goes if there's a minus in front of the middle term, if there's a minus in front of b. Let's take a look at some examples. Okay, so let's see if this is a perfect square trinomial. Is 9x squared a perfect square? Indeed it is. It's 3x times 3x. Is 16 a perfect square? It is. It's 4 times 4. Now we need to ask ourselves, is this middle term, is 24x 2 times one of these times one of these? Is it 2 times 3x times 4? Does that give us 24x? Indeed it does. So yes, this is a perfect square trinomial, so I can factor it into, in the parentheses, squared, a 3x and a 4, and because there's a plus right here, I can put a plus right here. And that's my answer. And I really don't have to show any work. Here's another example. Let's see if this is a perfect square trinomial. Is 25x squared a perfect square? It is. It's 5x times 5x. Is 9 a perfect square? It is. It's 3 times 3. Is my middle term 2 times one of these times one of these? 2 times 5 is 10, 10 times 3 is 30. Indeed it is. It is a 30x. Now notice this one has a minus in front of my term that's b, so I'm going to factor this into 5x, because that was my first term here, and then a minus, and then a 3 squared. And that's the factored form of 25x squared minus 30x plus 9. Now we can do the same thing with equations. Remember, if we're solving a quadratic equation, if we're solving an equation that starts with an x squared or has an x squared in it, then most of the time we're going to make it equal to 0. So let's add 81 to both sides. And that's going to give me 4x squared plus 36x plus 81 equals 0. Now, is the left-hand side of the equal sign, is this a perfect square trinomial? Let's try it. 4x squared is 2x times 2x. 81 is 9 times 9. Is 36 2, because there's always a 2 in the formula, times 2x times 9. 2 times 9 is 4. 4 times 9 is 36, 36x. Indeed it is. So this can be factored into 2x, because there's a plus here. There's a plus in my answer. 9 squared equals 0. Remember, this is an equation. Now remember what that means. This means 2x plus 9 times 2x plus 9 equals 0. Since it's the same thing being multiplied by itself, I don't have to write it twice. Remember, normally we would write 2x plus 9 equals 0, 2x plus 9 equals 0. Because this is squared, I only need to do it once. I'm going to get the same thing for both of them. Subtracting 9 from both sides and dividing by 2. My answer is negative 9 over 2. Notice this one's a little bit different. There is only one answer, and that's okay. Remember what I said is because my biggest exponent is a 2, I can have as many as 2 answers. Also means I can have one answer or I can have no answers. Here's another example. Oh good, we get to do some fractions. Let's see if these are perfect squares. Of course, x squared is. Now, is 4/9 a perfect square? Well, the square root of 4 is 2. The square root of 9 is 3. So yes, 4/9 is 2/3 times 2/3, or 2/3 squared. Now, is my middle term, is 4/3 x, 2 times an x times 2/3. Remember, 2 is 2 over 1. 2 over 1 times 2 over 3 is 4 over 3. Indeed it is. So this is a perfect square trinomial. So this is going to factor into x minus, because I have a minus there, 2/3 squared. And since this is an equation, it equals 0. So that means x minus 2/3 equals 0. And adding 2/3 to both sides, x equals 2/3. Okay, so here's a new property. Remember, we had the zero product property, which we just used. Now we have the square root property. If x squared equals n, then x is equal to the positive or negative square root of n. Basically what I did from x squared equals n to x equals plus or minus the square root of n was I took the square root of each side. So let's try an example of this. Suppose I have 25 equals n. If I take the square root of both sides, and I have to put a plus or a minus here, yeah, that means that 5, you know what, I think I did that backwards. My mistake. Sorry about that. Let me try this again. If x squared equals 25. There we go. Sorry about that. Now if I take the square root of both sides, that makes a little more sense. And this has to become a plus or minus because remember, there are going to be 2 answers here, and I'll show you why in just a minute. Now it's almost as though over here, the squared and the square root cancel each other out. So that leaves me with x equals plus or minus 5. Now, does this make sense? So that means x is a positive 5 or x is a negative 5. Is 5 times 5 25? Indeed it is. Is negative 5 times negative 5 25? Indeed it is. So let's use the square root property to solve a couple equations. Now I'm going to break my rule that says make it equal 0. And the reason I'm going to do that is because I notice that the left side of the equation is a perfect square. So if I take the square root of the left side of the equation, and on the right side do the same thing, take the square root, it's almost as though the squared and the square root cancel each other out. What I will be left with is x minus 7 equals plus or minus the square root of 36 is 6. This becomes 2 equations. This means x minus 7 is equal to a positive 6, and x minus 7 is equal to a negative 6. Adding 7 to both sides, x equals 13, and x equals 1. So if the left-hand side of the equation is a perfect square, or can be written as a perfect square, use the square root property to solve for x. Here's another example. I'm going to use the square root property and take the square root of x plus 3 squared, knowing in advance that those are going to cancel each other out, and then plus or minus the square root of the right-hand side, which is 2. So my square root and my square cancel out, and I'm left with x plus 3 equals plus or minus. Now remember, the square 2 is not a perfect square. It's not 1 times 1, it's not 2 times 2, so we're just going to leave it that way. The square root of 2 is actually a lot like the number pi. It's an irrational number. It cannot be written as a ratio. It cannot be written as a fraction. It's a decimal that goes on forever without ending and without repeating. So we're just going to leave it as a square root of 2. But this isn't my final answer because I don't want to know what x plus 3 is. I want to know what x is. So I'll subtract 3 from both sides. So x equals, and now this minus 3, so we don't get confused as to whether or not it's under the radical sign, we're going to put that out front. So negative 3 plus or minus the square root of 2. Now that's a funny looking answer, but it's perfectly correct. And remember, that means it's actually two numbers. X is equal to negative 3 plus the square root of 2, and x is equal to negative 3 minus the square root of 2. And let's try this one right here. The left side doesn't look like a perfect square, but let's see if we can factor it. Let's see if it is a perfect square trinomial. 4x squared is 2x times 2x. Square root of 1, 1 is 1 and 1. Is the middle term 2 times one of those times one of those? Indeed it is. 2 times 2x times 1 is 4x. So actually this can be factored into 2x plus 1 squared equals 15. Now I'm going to go ahead and use the square root property and take the square root of both sides, knowing that taking the square root is going to cancel out my square. Don't forget plus or minus the square root of 15. So that gives me 2x plus 1 equals plus or minus the square root of 15. And in this case, 15 is not a perfect square, so I'm going to leave it like that. But I'm still going to solve for x by subtracting 1. So 2x equals negative 1 plus or minus the square root of 15. And then divide both sides by 2. And I'm going to get a very funny looking answer, which is perfectly correct and perfectly exact, and may look familiar to some of you who have used the quadratic formula before. X is equal to negative 1 plus or minus the square root of 15 all over 2.